Right, this is the first section from chapter 10. So chapter 10, the main takeaway here is vocabulary. If you understand the vocabulary, all of these problems hinge on you drawing pictures correctly. So we've given you the vocabulary page. All the vocabulary is in the book. These are some of the more important definitions from 10.1. So concentric circles, meaning they have the same center. If two circles are congruent, that means they're radii, which is the plural for radius. Their radii are the same measure. Interior and exterior points. So an interior point would be inside the circle, meaning if we were to connect the center to that point, it would be less than the radius. And an exterior point is outside the circle, meaning if we were to connect the center to that point, it would be longer than the radius. And a point is on the circle if its distance from the center is equal to the radius. Okay? So chords and diameters, those are what we're going to be working with primarily. So a chord is a segment that joins any 2 points on a circle, and a diameter is a chord that passes through the center. So when we are solving the distance between the center and a chord, when you're asked to find that length, we look for the perpendicular measure. So what we do is we draw a segment from the center that is perpendicular to the chord in question, and that is the distance we're looking for. So let's jump right into a problem to practice that. On number 1. The radius of a circle is of circle O. Remember, we named circles by their center, so that would be circle O, meaning the center is point O. So the radius of circle O is 13 millimeters. The length of chord PQ is 10 millimeters. Find the distance from chord PQ to the center O. So I'm going to draw my circle. So here is circle O, meaning our center is O, and I've got some chord PQ. So I'm going to draw a chord. And here are points PQ. And I know the length of chord PQ is 10 millimeters. I want to find the distance from the chord PQ to the center. So that would be this perpendicular measurement here. Now, when I draw this perpendicular segment to PQ, it's going to bisect that chord, meaning if it was 10 millimeters from the beginning, each of these pieces is now going to be 5. And I can draw in the radius of my circle because that's the other piece of information I was given, that the radius is 13 millimeters. And you can draw the radius anywhere, so from the center to any point on your circle. But where it's helpful here is to draw it to the end point of that chord. So either to Q or to P. Either way, this forms a right triangle where the radius is your hypotenuse. So I've got a right triangle where I know the hypotenuse and one side, and this is actually one of our triples, and so that missing side is 12 millimeters. Now, if you didn't remember that this was a triple, you could always use Pythagorean theorem. Okay, so that distance from O to PQ is 12 millimeters. Okay. On to number 2. Find the length of a chord that is 15 centimeters away from the center of a circle with a radius of 17. So again, let's draw this circle, and we're not given points here, so I'm going to name this circle A, and I'm going to draw in a chord and name it BC. So we're looking for the length of BC, and we're told that this chord is 15 away from A, so that perpendicular distance is 15, and we know the radius is 17. So again, I'm going to draw in that radius from A to the endpoint B, or you could draw it to C, and I know that this distance is 17. So again, I now have a right triangle, and I can use Pythagorean theorem, or this is actually a triple as well. And this is 8, which means this is also 8. So the total length of that chord is going to be 16 centimeters. Okay. So on the next page, this is summarizing what we have talked about here. And again, these tick marks got shifted down when this was printed, unfortunately. So what this is showing you is that when we draw that perpendicular segment, it bisects the chord. That's just summarizing what we've already shown and used to solve the first 2 problems. All right, let's look at number 3. Find the radius of a circle if a 24 centimeter chord is 9 centimeters from the center. So again, let's draw our circle, and this time we're looking for the radius. Let's call this circle M. And I'm going to draw in chord NO. So again, we're told that it is 9 centimeters from the center, so that perpendicular distance is the 9, and the chord itself is 24, which means when it's bisected, each of these is 12. And I'm looking for the radius, that hypotenuse of our right triangle. So again, this is a triple. This is part of the 3, 4, 5 family. Each side's been multiplied by 3. So that third side, the hypotenuse, is going to be 15 centimeters. All right, and then last but not least, number 4, we've got two circles that intersect and have a common chord that is 24 centimeters long. The centers of the circles are 21 centimeters apart. If the radius of one circle is 13, find the radius of the other. So, intersecting circles. What that's going to look like is kind of like a Venn diagram. Okay? So, here are my intersecting circles, and we know that their centers are 21 centimeters apart. So, I'm going to draw that in here. This is 21 centimeters. And they have a common chord. So, that would go between these two intersection points, and it is 24 centimeters long. And then we're told that the radius of one circle is 13. So if I were to draw a radius, where have I been drawing all of my radii in these practice problems? That would be from the center to the end point of the chord. So I'm going to do that. So this is a 13 centimeter radius. Now, what I'm wanting to find is the radius of my second circle. Okay, so from the center to the chord, that intersection point of the chord and the circle. So this is what I know, this is what I want to know. And I'm given this information and this information. So let's look at what we can find with the radius being 13 and the length of the chord being 24. If I draw in that perpendicular distance between my first circle's center and the chord that they share, it's going to bisect that chord and make each of these 12. And so that distance perpendicularly leaves us with 5. That is a triple, but again, you can use Pythagorean theorem if you did not recognize that. So this distance is 5. The entire distance between the centers is 21, which means the remaining distance would be 21 minus 5, which is 16. So what I have now is the distance between the center of my second circle and that common chord. I know that this is still 12 because it was bisected, and I now have another right triangle that I can find the hypotenuse on, which is going to be the radius of my second circle. This is also a 3, 4, 5. Each side's been multiplied by 4. So that radius of our second circle is going to be 20 centimeters. And that wraps up notes on 10.1.